Hi, I'm Tim Sutton. I'm a Mac sysadmin. I'm from Montreal, and I work at Concordia University and Faculty of Fine Arts. So I'm here to talk about Python and tell you guys hopefully why it's a interesting language that you should consider learning or taking a look at if you haven't yet. It's a really popular language in our community, especially. There's a lot of projects that use it, so there's a lot of interesting work to look at to get started. This is a URL that has a bunch of resources that I'm going to be kind of stepping through in this talk. It's going to be quite a lot of information, dense, closely packed in terms of what I'm going to be talking about. So you don't have to necessarily follow along, but that's just a URL you can go to clone or get a copy of it if you want to follow along later. So what I'm going to do is I'm going to talk about, I'm coming at this kind of from a perspective of the way I learned Python was really just by finding a way to replace Bash in what I was doing with my daily work. So that was Bash scripts that would be running on my own admin workstation to do Bash processing or interfacing with servers, SSH in a for loop, whatever. Or it could be things that were running on a client as well. So there's a lot of cases where I manage a lot of shared workstation type setups at Concordia, and this often means we're writing a lot of small scripts that will do things like manipulate preferences or check for things, make sure a system is in kind of a known good state, first boot scripts, run on startup scripts, this kind of thing. So that's kind of where I came at learning Python, and so I'm going to come at it from that angle at first, and then we'll just jump right into examples. Things that we do, things that I do at least with Bash, and I think are pretty common. So we definitely need to be able to do things with the file system. We need to be able to copy files from one location to another, check whether files exist, whether we have permissions to write to them. We need to synchronize files from one place to another. We often need to parse these files. So on OS X, we have lots and lots ofplists everywhere, store a lot of important information. If we're doing things like where we might be interacting with some kind of a web service, if you run Casper and you have a JSS, you want to automate some aspect of that, you'll often be doing things dealing with like running curl, getting a response back, parsing that response. So you'll be dealing with XML and JSON quite commonly. So in Bash, I see some cases where people want to automate that kind of thing with Bash, and you end up seeing things like this, which doesn't quite show up, but basically does. That's using XPath and sed to try to parse a value out of an XML file, which is kind of it's quite painful. We also often just have to run commands that are OS X specific. So this is a list of utilities that are all on OS X systems, and we often have to use these for things like packaging, for dealing with our disk partitions, file vault, installing files, managing the services. So all these things, even if we can do more things in Python, we still need to interact with these utilities as well. And sometimes there just isn't actually a tool available that's a command line tool or a command line tool that can do exactly what it is that we want. This is just an example of a tool that I was able to write in Python just using Python and Apple's own frameworks through a system called PyObjective-C. I had a need to be able to install a color sync profile on a machine through the command line, and there wasn't really a good way to do that. There was definitely an OS X API for doing that through a GUI application, but there was no tool that could do it, that I found anyway. But with Python, I was able to do that. So there's cases where in Bash or in a shell, you still wouldn't have necessarily the ability to use the built-in tools to do what you want. This is a short list of complaints that I have about Bash, or just things I run into whenever I start writing a shell script that will maybe need to do something more complicated. So anything where you ever have to deal with spaces in pretty much anything, you'll have issues with quoting or trying to understand if you're going to parse a bunch of output from a command, separating something by spaces. How will you know whether the space is actually a delimiter in a different column of data, or if it's a space in the thing that you're actually parsing out? Trying to loop over separated data. There's this whole thing with this internal field separator. I'm not a bash expert by any means, so there could be some things here that there's better approaches to doing if you're actually a bash expert, but things that I get bitten by very quickly. There's the notion of arrays in bash, but again, we don't really have sort of rich, complete objects to be able to, or we don't have data types that are richer than strings and lists of strings. In some cases, I might want to be able to take a bash script and port it over to some other platform. There's things on OS X like, for example, find and sed. If you look up things on Stack Overflow, trying to just say, okay, I need a command to give me, using find, to give all the permissions that have all the files that have a specific permission. You might find you get an answer, but it only works on Linux. So on OS X, there's tools that are the same name as those on Linux, but there's GNU and BSD variants of those tools, and the options don't match up in all cases. So your scripts might be less portable if you want to move them from one operating system to another. Handling issues, handling errors. So you might have a bash script where you run something, there's an unexpected failure of some command, or there's a permissions problem, and you have to be aware of whether it's okay that your script might just keep going if there's a problem, or you might have to be extra strict and make sure that your script exits immediately on any error, but then you might have cases where you want to check something based on the error output. So there's a kind of, you might want finer grained control where you have a more safe way of checking for unexpected things to happen. And then also, as a bash script grows in size, it gets more complicated to maintain it. So Python, I think, addresses all those issues, but there's also just other nice things about it is that it includes, there's this notion called batteries included you see a lot with Python, which is just basically to say that the standard library includes quite a lot of useful functionality just out of the gate. So there's a ton of great third-party packages as well for Python, and certain things like dealing with web requests. You may well want to use a third-party package. That's another popular package to use. But for many things that I at least use in my day-to-day on managing client systems, the standard library can do an awful lot. And so I find that there's a lot of things I don't need to shell out to system commands to do for me, except for those OS X specific ones. Getting back to the error handling and safety issues with Python, you can control the execution flow of things that handling all kinds of cases that you might run into. It sort of forces you to do that because in Python, if you have if something unexpected happens that you weren't programming for defensively, your script will just crash. Because it is a real programming language. If a program does something that you didn't handle in the code, it will abort right there. So it does force you to engineer more handling of the failure modes of whatever it is you're doing. On OS X specifically, there's this project called Python Objective-C. It's not maintained by Apple, but they include it on the OS with the same Python that they ship. And that's what lets you actually very conveniently just access a ton of OS X APIs directly from within your script. There's an issue where you might have a different Python than the one Apple ships, and in those cases it might be trickier to use it. But because the stock Python is there, and it's the same version on every OS X, up until from Lion to El Capitan, it's the same Python 2.7, so you can count on it being there, the same version on every single system with basically all the same frameworks. So it's reliable in that sense, or predictable. And then Python is, it's a very well understood, it's a mature language, it's been around for a long time. A ton of people use it in many different domains, so there's a lot of good information out there on how to use it. Okay. So that's my spiel, and I'm going to skip in my little snippets here. There's some basics that I'm just not going to. I'm going to skip over them, and we're just going to get straight into the examples. Actually, and the other thing is I'm going to do this all through an interactive, almost all through an interactive Python prompt. So if you're at the terminal, you can just type the word Python, and that will give you an interactive Python environment where you can just type commands and you'll get results back. This is basically equivalent to if I would write these commands out in a script, but this is just a more interactive way for me to show you. And I actually prefer using this one that's called IPython. which you can install pretty easily. You can actually just do it. It would be a sudo easy install Python, or if you know pip, you can install it other ways. It would be IPython. So that has a lot of conveniences. Okay. So with Python, we have all these modules. So one module that's very, very useful is called plistlib. And this is on, again, this is on the same, this module exists, Python you would install anywhere. So it's a pure Python implementation of parsing plist files. So just as an example, so I'll have a variable I call plist path. Can everyone see that? Okay, good. Let me know if it's too small. And then I'm going to assign it to this path. So this is a string because it has single quotes around it. And I'm saying the path is the system version plist. And this contains information about what version of OS X we're on. And then I'm going to say, OK, my variable called plist is equal to. And so then I'm going to say this is the module name here. So I'm saying the module and then dot read plist. So this is a function provided by the plistlib module. And then I'm passing it a single argument, which is the path that I just built up here. And what I get, which is really cool, is I get a dictionary, which is the same. It's the same structure essentially that what most plists use is a dictionary. So you have it's an unordered collection of items. So you have a key name. In this case, I have product build version. That's the key, and this is my value. A key and a value. So you have the key, and then the representation here is with the colon, and then the value. And then you've got these curly braces around the side to indicate that it's a dictionary. And so what's nice about this is that I can refer to these keys directly with the syntax of having I use square brackets just to indicate, okay, this is a plist object, and I want to get the key for product version. And that's just going to give me that. So compared to something where I might try to be parsing data using something like plist, well, people often use defaults to try to parse a plist, and you can do that, but you'll run into cases where a Boolean will show as 1 or 0, and an integer will show as 1 or 0. And if you try to parse that data, you don't necessarily know exactly what data you're getting, what data really lives inside the plist. And plistlib could show you that kind of information better, but plistlib has a very eccentric syntax, should I say. Plist buddy. Yeah. Anyway, but what this also gives us is the ability to get the sort of actual data types that are contained within this. So in this case, I only have strings, but for example, this string that I got has a space in it, but I know that if I'm going to actually refer to something that's inside the product copyright key and I'm going to manipulate it or something, I don't have to deal with whether or not it might contain a space in it, and then I have to make sure that I have the right kind of quotes around it, and if I want to be able to substitute a value into that it's the right kind of variable substitution syntax. I'd have to make sure I get right if I'm doing this in a shell. So yeah, again, just getting access to the actual data that's inside a plist is pretty useful. And so just as a simple example, I can have an if statement here that would just say if this, so this is a string, and then I can call, in Python, you have this notion of functions and methods, but they're essentially the same thing. Just the nomenclature is more just that we'll say objects typically will have different methods that can be done to those. So this is a string. Strings have different methods that you can call on them, and one of them is called starts with. And so if the string starts with 10.10, then we can set conditionally SIU, so system image utility path, to this. Otherwise, it's something else. And then we just have this. There's different ways to get the version of a OS X system that it might be actually safer than reading a plist file off disk. There's a couple other options that are in this file here, just as an example. There's other modules that provide the same information, but this is just a useful example. That plist product version, if I assign this to something, What's nice about IPython is that if I just type so this is a string, right, that I just took out of the plist that I had. If I just say dot, I get an auto completion showing all the different methods that strings can do, or any kind of object. So that's why I prefer this editor, because it makes it a bit more discoverable to see what the objects can do that you're working with. I found that there's even a function there's a method called isTitle, and you can actually pass it something like, is this a title? I can't believe this is actually here. I haven't tried it with an A. Aw. I guess that's true. I just discovered that the other day. So the one drawback with plistlib is that it can only parse XML plists until very recently in Python, I think 3.4, they can now parse binary plists. And on OS 10, binary plists are very common. So there's one, the best solution on OS 10 was provided by Greg. And when he wrote Monkey, I think around the time that he wrote Monkey, he wrote this module called Foundation plist. And so this is a single file that can work like a module. You would include this file in a project. I assume that it's included in probably a dozen different projects at this point. Maybe you should ask Greg nicely before you just go and use it. But it's a drop-in replacement for plistlib. So this allows us to read a binary plist. And this is what uses the Python Objective-C framework I was describing earlier. So it uses the same API that Apple uses to parse a plist instead of using the stock Python, pure Python solution. But this allows you to use the system that Apple or third-party Mac apps would use to parse a plist. And so it doesn't care whether it's binary or XML. Okay, so an actual practical example of dealing with plists. Go to, so I have an example here where I have, I use Monkey, and Monkey uses these things called package info files as the metadata for packages, and there's this notion of catalogs. This is a maybe contrived example, but I could see a scenario perhaps where I might want to be adding more batches of different catalogs to all my items that are in my repository. So in this case, let's say that I'm taking on like a new department or a new business unit in my organization that I'm going to start managing with Monkey. And so I've got maybe 1,000 different package info files in my repo, and I want to sort of bulk add a whole bunch of maybe different departments into all of the catalogs that are listed for all the items, at least just as a starting point. And then at some point we might start branching off different units into different sets of package info files. But essentially all I really want to do here is I want to take, so this is a key called catalogs, and it's an array. And I just want to add one more item to the catalogs array of each plist file. So what I want to do is I want to iterate through every plist file, read the plist, check to see if the catalog I want to add is already in the array. If it's not, then I want to add it. If it's already there, I want to just keep going. That way it wouldn't get added twice. Or I might have cases where I've already added some manually to test. So this is a more complete example, and this is actually, you would run a Python script just in the same way you would define another scripting language, where you can define with this line at the top what executable is going to be used to run the script. And so in what we've seen before, this is the part where I'm doing a read plist file. I'm assigning that to the variable package info. And then down here, I'm saying if this catalog, so I've defined up here the catalog I want to add. If that catalog is not in the catalogs, so when Python imports this plist or loads the plist, it's going to convert what plists call arrays into a Python list, which is essentially the same thing. Then I'm going to call this append method on the catalogs list. Okay, and so that's going to add it to the list. Finally, I'm going to write the plist back to disk, and I'm going to overwrite the original in this case. Probably I would do this I would at least back up my repo before I would do this. But at least we're adding more safety by making sure that if it's already there, we're going to just move on. Okay, and then so the part that's actually letting us loop over all the plists is there's this function called glob, which is what lets you do a shell glob syntax, which is you give it a path, and I'm giving it a wild card saying .start.plist. So there's different ways that I could get all the items in a directory. This is just one I preferred to use in this case. I don't have to filter out whether the file's a dstore file, or I have to check if it ends in plist. This is just a simple way to do that. If I would call this function, just as an example, Python port glob. So this is from the glob module. This will just return a list of all the things that are in that directory. And this is all relative. I'm giving a relative path. There's a module that could just, like os.path.abspath could just give me the absolute path if I wanted that. Let's just look at what happens if we run this. Add new business unit. So again, all these things don't have anything there. If we run this. Okay. And then the ones that it succeeded on, now I have it. Very simple. But in the cases, so like there's two, can you see that? Yes, okay. Malformed plist, skipping this, couldn't write this to disk, verify the permissions. So if I didn't have some method to handle these error cases, then the script would crash. I'm trying to be safe here anyway by just making sure I don't add it twice. So it probably wouldn't be a big deal, but I want to sort of demonstrate a case where you at least want to handle gracefully some errors. And then if it's a utility that you're going to be using yourself later, or you're going to give to other people to use, then you can actually output more useful error info, which is much more useful than just someone getting a crash and a traceback, and it doesn't really explain what actually happened. So the way that we do that is with this system called try and accept. And so when we try to do something, we put it within the try block. We can have as many statements here as we want. We could wrap the entire script in a try block if we wanted, but that would be, we wouldn't be able to catch specific errors so easily. So we're just saying, this is the one thing I want to try. I know this might fail. If it fails with, for example, this error is the XML parsing library, at least this particular one, expat. It's an error raised when it can't parse the XML properly. So I would say, OK, except for this exception, print this output. Continue is just going to say, continue to the next iteration of the loop immediately. Stop running the current iteration. Except IO error. IO error is raised if there's a disk permissions problem, if it can't find the file on disk, for example. And then finally, so now we're sort of out of the try block. We're doing our add to the catalog, and then we're going to do at the end, we're going to try the write. So because maybe we were able to read it, but not able to write it. With Monkey, because people typically set it up with like an SMB repo, people can wind up with all kinds of weird permissions issues and UMask creating weird permissions that they then can't go and modify the files. So this would catch those kinds of issues. And so that's why, in this case, it couldn't do that, but it just kept going. If you were to and show you what would happen if I took this out, and then I rerun this, what will happen? So that's what a traceback actually looks like. And it's not that it doesn't tell you anything about what happened. Like, it's actually pretty clear. Permission denied on this file. Okay, so someone could probably figure out what's going on, but it does mean still that your script would halt immediately. Nothing more would happen. So how do I know what exception to actually catch? I did this. But I just looked at the exception name will be here at the beginning. And that's what I'm putting in here, except this. Okay, so that's plists. Other things that we do with scripts is we run commands. We do that with the subprocess module. I'll import this too. So here's an example of, let's say I wanted to build a package. On OS 10, there's this tool called package build, and it's a pretty simple utility to just build a package at the command line. And this is a really simple syntax of saying, I just want to build a package out of Wrangler using this component argument and giving it a bundle, which is the application. The way that I do this, I say, here's my command, has these elements, and then I say subprocess.call, and then pass it the command. And then what happens is that it immediately forks and runs this process. All the output from the process comes out to standard output directly when I'm doing it this way, and then I get back the return code as 0. So what happened, if we break this down a bit, so the first thing that's kind of different if you're used to looking at how you would do this in shell is that the command is actually a list of elements. It's not like it's not one big string with my command component, like where I'm just typing it out as one big blob of text. So the shell, in the shell, it has to figure out what your command is and then what all of your arguments are. It has to parse those things apart and then uses spaces to determine what your arguments are, and that's why you get into quoting hell with trying to escape spaces. Or double escape things, even worse. So if you've ever looked at a launch daemon or launch agent plist and you see a thing that says program arguments, and then it's like you have to give it a list of the first thing is the executable, and then each argument is its own element. This is really the same idea. So it's not actually running the command through a shell at all. It's just running the executable with these arguments. And then we can specify additional things, like if we wanted to pass in our own environment, we could still do those kinds of things. And you actually can run it through a shell if you must. So you could say, just call this. And in this case, I'm giving it a string. So this is really like saying sh-c and then running this command. And the way that I do that is there's an optional argument called shell, which I pass true. And that's just saying, OK, just run this through a shell. But I've never actually had a scenario where I have to do this. You open yourself up to all kinds of, obviously there's an example even here of like you're vulnerable to the shell shock issue even if you would do this. But moreover, you just have to deal with all the escaping issues, and you're kind of back into that world of doing it through shell again. So maybe there's some extreme cases where this would be useful, or there's some other tooling that you're relying on that really is assuming that you're doing all this through a shell, perhaps. But generally, we don't have to do that. At least I don't. But how would we handle errors? So in that example, we just ran the command. It exited 0, but we wouldn't have been able to do anything if it didn't exit 0 or if we wanted to do something more with the output. But the command did return a return code, right? We saw a 0 at the end. So I can instead say the return. So I assign the output of this function, the call function, to a variable called return code. Because I gave package build a bogus path, it just is going to spit out on standard error. Here's the error, doesn't exist. And then if I look at my return code, it's 1. So I could have some code, for example, that would just say if return code, so if the return code value was non-zero, if there was anything but 0, print out to the standard error then that the command exited this, and then you could handle that case differently. You could actually, if your script depended on being able to run this thing and there's no point in continuing if it failed, then you could exit the script right then. That's a simple example of just running a command, but often we want to run a command and we want to actually get the output from it so that we can do something more useful with it. Or we might want to run a command and feed standard input into it. So we use the big brother of call, and we're going to use something that's called popen. So the example that I'm going to show just quickly to show you what this would normally respond with. So dsconfig.ad is a utility to configure directory services, Active Directory specifically, config Active Directory. And if you do the show command, it's going to print out all the settings that you typically see in your AD binding settings. If you ever look and you see policies for passwords and the domain and how homes are mounted, that kind of thing. And so if we run this, we can also specify that we want XML output from all that info. And so now we have all that data in a nice structured format. And so we could then go, if we needed to, for example, scoop that information up to feed back into our management system. In Monkey, if we wanted to perhaps put that into a condition or a Casper, an extension attribute, you could then run a command and then pull these values out. So how would we actually do that? That's where this popen command comes in. So here's my command again. So the full path. Don't always have to use the full path, but it's generally recommended. If you know what it is, then you remove the variable of, if you're going to run this in some unusual environment where the path might not actually exist or be what you there's no reason really not to use the full path unless you expect it might exist in different places. And then my arguments show in XML. So instead of just saying .call, this time we're going to use this construct called popen. Instead of returning an integer of the return code, this is actually going to return an object called popen. It's a class, so you'll get back an object. If I say, what kind of class is this? It's a popen object. So it's a process that's been opened. I'm going to pass it these two additional arguments, standard out, standard error, and I'm giving it a special reserved word called sub. This is again, within the subprocess module, this is an attribute called pipe, and that's just a reserved kind of namespace, like a placeholder to tell it, I'm going to keep the data sort of a part of this object, and then I'll give you the ability to scoop it out yourself and then put that into something else. So it's kind of like the equivalent of a shell pipe, guys, and that's why it's called that. You could also put, if you open a file to disk and you want to just log this output to disk, you would say open a file, give your file a name, and then you would just say standard out equals my file object, and it would go there instead. So, but because we want to actually get the output right away, we can just pipe it. And then the output that we want to get, we get by calling the method communicate on the process object. What we get back from that is the standard output and the standard error, which came because we specified that we're going to want to get those from here. Okay, and then because this is a special, like this is actual an object that has methods, we can see we can like send a signal, kill the process if it was still running. We can ask it that we want to wait. So communicate just gave us back our output. You can see, okay, we didn't get any error output. But the output is just a big giant string with these /n's are new lines. So this is why it's pretty unreadable. But we got new lines, spaces, new lines, spaces, right? But this, we can see that our entire p list is actually right here. So here I did a bit of just extra safety checks. So I said, if there's an output at all. So if my output was non-zero, or if my output was just an empty string, then probably something went wrong, and I might want to log any error output. So I'm saying, if there was output, if there was any output, and the process exited 0, then I'm going to read the plist. So, and then the ticket here is that instead of saying just read plist and a file path, there's another method called read plist from string. And I already assigned the output to the out name. And so now I have my plist again. There's a lot of plists in this demo, I'm sorry. But so then, again, I can just say general info. And I can just get my data out that way. And I could record that somewhere else if I have a system that might want to pick that up. And just in addition, there was actually a lot of these kind of core management utilities that are command line. A lot of them actually support plist output as just an option. So something like diskutil, for example, if I run diskutil and I want to say, like if I would want to get the volume name of my booted volume, and this has a space in it, this would actually be hard to do in Bash properly. I'm not really sure how you would actually do that. You would have awk, and then you would try to figure out which column. Anyway, so you can say diskutil list plist, and then you actually get more information this way too. So you could actually go through and kind of pull out the info that you need, and then not care what it has in it as long as it's a string. And System Profiler has a ton of information too in a really weird format, but there's some tools that already have kind of figured out a way to just abstract that out. Okay, what am I doing for time? Okay, so we've looked atplists a lot. Because again, I manage a lot of shared workstations, I tend to have to do a lot of preferences tweaking. And there's been a tendency lately where historically people could modify preferences by just modifying plists directly on the disk. And as of 10.8, there's a caching system that runs underneath the preferences as part of the preferences system. And so applications don't ever directly open plist files to modify preferences. They just tell the preferences API, set this preference, get this preference for whatever application, whatever the identifier is of this application. So that's all to say that it's not actually safe to just modify a plist directly if we want to set a preference. So anything that's in /library/preferences or in the user library, that's all stuff that you should actually be using the preferences system to make changes to instead of trying to read plist files on disk. So you might see that, yeah, your changes to preferences get written to disk, but if you that for one that's not synchronous, when you make the change, it may happen sometime later in the future. And if you make a change directly to a plist file, you're pretty much guaranteed that that preference will just get discarded unless you restart the whole daemon itself or the computer, which people do, but you shouldn't. So in Python, with PyObjective-C, we have the ability to just say, you know what, I can have access to Foundation is one gigantic module that the framework provides access to the system APIs. There's all kinds of other stuff, like there's core graphics, system configuration, a lot of other things. But I'm going to, and just for the simple example, I'm going to grab two specific methods. So CF preferences, copy app value, set app value. These are roughly equivalent to like a defaults read and a defaults write. And we don't ever have to know anything about plist paths. We just have to care about what domain we're managing. So that's the reverse domain Java style, and then whatever key we might want to try to get. So right now, if I say, give me the home page preference for Safari, I got back a none. So in Python, there's a special type called a none type, and that's basically saying, yeah, the object exists, but it's nothing. It's just basically, it's just there, but there's nothing you can really do with it except check whether it's none or not. This API will just give us back a none if that key wasn't found. So if I open Safari and I see that my home page is not defined, it's defined, but it's defined to the default. Simplest possible example. I'm going to set this to, so I say set app value, the key, the value. So in this case, it's the URL and the domain. It might still open the old page, but it sets it. Right? If I make a new page, it'll actually open it. And so this is like the simplest example possible. It is the equivalent of basically saying defaults read Safari home page, right? But we again have the ability of getting the access to the sort of complete to the object that really stores. Right. Within the dictionary of the preference, we get the actual object that contains that data. So if I say like this is just another preference, domains to never set up, which is an array, right? So I can the PyObjective-C framework gives us the ability to actually use Python syntax mostly to be able to get at the data. So I can index this in the same way that I would index the items in a Python list. So it lets you use these APIs, but kind of blend it in with all the rest of the Python idioms and style, and generally write a lot less code. So that's like the simple example of dealing with preferences, but I have a really crazy one, which is a really kind of extreme case, but it has to do with Adobe. So Adobe Reader, Acrobat and Reader have sort of very specific enterprise deployment tools and support for settings that they provide. On the Mac, you can do things like you can tell reader via a system location to not check for updates. There's support for a few specific things like that. If I would want to tell it, though, this key has always really bugged me. It's the EULA accepted key. And so the reason it bugged me was because I used to deploy reader as to a lot of machines where people would open a web browser and then find that they couldn't render PDFs because the reader plugin had been installed, and if they didn't first accept the EULA, the plugin would actually just render like a white page. It wouldn't even, like there wouldn't be any explanation of why it was a white page, and then help desk calls would come. And it would be during a class when someone is trying to actually teach their class. In more recent years, it's less of an issue now because browsers include their own PDF viewers. But still, if we install Reader, I would just like for the plugin to just work after it's been installed. So this kind of really deeply nested plist is a couple preferences that are set in the Adobe, so com.adobe.reader. What they do that's unusual is that they put each version as a top-level key, and they call this sort of a version hive. And so this lets them have a single preference domain, and then presumably they can use that to maybe migrate your preferences from one version to the next. But the issue is that because this is a top-level key, we can't manage this using a configuration profile. I mean, we can, and it will apply the setting, but configuration profiles and MCX and preferences, that managed preferences only manage a top-level key. And this EULA accepted is nested one level deeper. So you could deploy a profile that would set this, but then it would clobber all the user's preferences all the time. So it would work, but like they would all their state with the program, recent documents, any actual preferences that they set, which there are a lot of, would be clobbered. So this is like a good use case for you want to be able to use a more powerful interface to the preferences system that's not defaults. Like you could maybe do this with defaults, but it would be there's a bug in the defaults man page just saying that preferences can be structured in complex ways, making them very difficult to enter to manipulate with this tool. So we really want to use something that's more capable. And if we're using Python anyway, then we can just do it directly within Python. Okay, so right now if I open Safari and I drag in a PDF, right, I get this. So at least right now it tells me what I have to do, but people don't even necessarily want to read that. So I'll close Safari for good measure. But what I'm actually going to do here, so the solution to this problem is that I want to load these preferences, and then I want to insert my own preferences without clobbering the user's preference. So I want to first check whatever preferences are there, load them in, and then add these things in kind of surgically. This other big blob here has nothing to do with the EULA. It just has to do with the prompt to say, do you want to associate PDFs with Adobe Reader when it first gets launched? Right, if I launch Reader right now, same thing. I get the EULA. Yeah, I'm going to quit. So I'm going to say import these different APIs. I could also just say import foundation and use them foundation.function. I'm going to say these are 4 major versions that I know about with Reader. So these would each have their own top-level key. And I'm going to define this prefs. This is an empty dictionary, the curly braces. And then I'm going to say, OK, for every version in this, so this is going to go through 4 times and give me the version for each loop. I'm going to say, give me the preferences for that key in this domain. So we saw copy app value earlier, same thing. If we got something, so we're going through these different keys, we might get a none for some because they don't exist. If we got something, copy them into this final prefs object that we've created at that key. So we're literally just making a copy of their preferences. We're not touching anything yet. Because we're using Foundation, we're using the OS X APIs, we actually have to call this different method to make a copy. And that's because when you use preferences, they give you back an NS dictionary. So through Objective-C, you get this NS dictionary object, but it's immutable. You can't change it. If you would try to modify it, an Objective-C, you would get an NS error that gets converted into a Python exception, telling you that you can't change it. So there's a method called mutable copy, which is going to give us back a mutable copy of the dictionary, which ultimately we're going to stuff into our assimilated version. If that key didn't exist, we're going to still create it here. And using this little, again, the empty dictionary, just to say, OK, we're creating a new nested dictionary. That's all just been kind of the scaffolding for that particular version. And then we're going to say, if EULA accepted is not in this key, then create it and set it to true. So all of this was just to create a dictionary that has existing preferences, whatever existing preferences might be there, and then we're adding in the EULA accepted key finally, merging it in. There's this set multiple command, a method that we can specify that will just say, instead of me assigning a specific key, here's the dictionary with all of them, and then the domain, and then we can even set the scope. We could say this is a by host preference or something if we had to. And then if you're on before 10.8, you have to call synchronize to tell it to actually save those changes. Okay, so finally, see how preferences are script. So again, reader didn't have the EULA enabled. If I do a defaults read, reader, I have a few preferences here that were set for DC, but no EULA was accepted. There's no other versions. And then if we run accept the reader, so it logged, okay, it did find this key, it added the EULA accepted key to it. All the other ones, it didn't exist in the first place. Now if we do a then defaults read, our DC one has our EULA accepted key in it, and then all the other ones just have basically everything, like the bare minimum. They have just whatever is needed for Adobe Reader to be happy. And then if we launch Adobe Reader, we see there's no more EULA prompt. And then if we open Safari, open Safari, drag in our PDF, then there's no more prompt. File doesn't begin with, OK. That's weird. But it loaded. OK, so that's the end of the kind of interactive examples part. So just some more further reading. There's a couple places you can steal a lot of Python code from. So Monkey has a lot of specific functions for handling all kinds of OS X specific things, everything that it has to be able to do to install packages and check the state of the machine, deal with disk images, web requests. It uses now Apple's APIs for actually doing all the web traffic, which is interesting. And then the Google folks have this module called gmacpyutil, which abstracts out a lot of interesting, well, it's just a module that lets you, again, sort of avoid having to write your own code to manipulate, to run these commands yourself and get data back from them. There's actually a lot of information in there. And then this repo that I made called Python MacAdmin Tools is just literally, it's a single README that just has a list of any tool that I've heard of that's sort of in the Mac IT, Mac admin space. I put up on this. So there's a ton of different utilities. Some of them are sort of, a lot of these things might just be a single script, but in some cases they're like a web application or solutions for imaging, deployment. Papine's projects here. Graham Gilbert has a bunch of projects. And a lot of these tools actually have been written by people who maybe 2 years ago hadn't really written any Python at all. So it's kind of a testament to how easy it is to pick up, and then how quickly it is to be able to do something effective with it, and then share it with other people. And then people tend to it kind of feeds on itself, and more people are learning. And then just lastly, a couple of tips. If you do get into using Python, you can install what's called a linter, which is a tool to give you just feedback on style or let you know about errors, syntax errors that you might have kind of buried in your code that you didn't know about. I use Sublime Text quite a bit, and it has a plugin called Sublime Linter, which will just show you, like, you can't see that too well, but that's a list of all kinds of style violations that I have in this file. And then what line they're on, it will highlight them for you. And then there's this tool called Dash that I use a lot, which is for just being able to quickly search. You can bring up with a keyboard shortcut, give you You just start typing in method names or documentation keywords, and it will just quickly navigate to the real documents. They scoop them, they scrape all the HTML for all these different programming language documentation, so you're still seeing them all formatted nicely. There I just started searching CF preferences, and it just took me to the Apple docs. If you use Alfred, it's got Dash integration as well. You can just start typing, and then you click enter, and it just takes you right to the method. Super useful. There's like 150 documentation sets or something they have. So they have things for not just Python, but all these different popular Python modules like Django and Flask. Those are all there as well. A few more resources. Dive into Python and learn Python the hard way are a couple good resources that I've seen. Stack Overflow is usually pretty good for how do I best do this in Python. And with Python, there's not generally more than a few ways that are kind of understood or accepted to be the way to do things. So it tends to be that the best answers do bubble up to the top. And then in Freenode IRC, there's a good Python channel as well. Thanks.